Dekebo from Department of Applied Chemistry, Adama Science and Technology University, Ethiopia. His topic is bioactive compound from resins of some Commiphora species. So the floor is yours. Prof. Aman, please.
Okay, good evening. My name is Aman from Ethiopia. And first of all, I would like to thank the organizers of this conference, Professor Anna and also Professor Vinod, for introducing me to this event. Thank you very much. Actually, it was my dream to see Brazil, because I know Brazil from my childhood as a football players country and also with Amazon forest. So it was just my dream, so it became true today. That's why I'm here. So the title of my presentation is Bioactive Compounds from Resins of Some Commiphora Species. And I am from Adama Science and Technology University. This one, okay, this is my country. Ethiopia is in the eastern part of Africa, which is in red. And Ethiopia is one of the oldest country. It has a lot of history. It is a country with origin of humankind, and it also has a lot of histories. Maybe you can read. And we have about 80 ethnic groups with 80 different languages. As you can see here, these are some few of them. Even we don't know some of them. And a lot of cultures is there. So we also have a country with different landscape. We have the lowest landscape, the lowest depression in the world, and also we have middle and highlands in my country. Because of this, we have a lot of hotspots for biodiversity, about 280 mammals, 860 birds, 280 reptiles, more than 6,000 plant species are there. Most of them are endemic to my country, and also some of them are most of them are less studied. This is my university. It is in the it is only 100 kilometers from Addis Ababa, our capital, and these are two gates to the campus, and it is one of the two science and technology universities in Ethiopia, selected by the government, and we have 8 centers of excellence. One of them is Institute of Pharmaceutical Science, where we are trying to furnish this institute. Hopefully within 1 year we have one of the best institute in the country. So this Commiphora species is one of known plant species in my country. It belongs to the family Bruceraceae, and it found in lowlands places in Ethiopia, arid places in Ethiopia, and also eastern part of Africa, in Kenya and Somalia. And we have in worldwide around 200 species of Commiphora. Only in Ethiopia we have 50 Commiphora species, which are used for different purposes, like incense, like cosmetics, like perfumery, like insect repellent, and also as remedy for different diseases. So these are the plants we have. This paper shows gums and resins of Ethiopia. We have not only Commiphora, we have also other gums like gum arabica, and also frankincense, and also Commiphora species. So these are the resins that we obtain from these plants. These resins can be obtained during hot season or by incision, by artificial incision. And this side shows people are engaged in this process in sorting out and making products for international market. So we sell them to different countries. So there is company that is responsible for this. That's called Natural Gum Marketing and Processing Enterprise. It is involved in this process. So this forest is also means of livelihood for many people in Ethiopia. So we export to different countries like China and also other Europe countries. So this is a plant. This is actually my advisor when I did my MSc, and this is like 20 years ago I started this work, and still I'm in this area. So this is a plant itself, the Commiphora myrrha, called myrrh. You know, everybody knows myrrh. This is a plant, and this is myrrh itself. So that is obtained naturally during hot season. So the plant uses these resins during hot season. And this is also another plant called Commiphora guddoti. It's also called scented myrrh. And this plant also gives this type of resins. So these are some of the exportable materials we have in Ethiopia. But still, even though we have all these materials, because of botanical information, less botanical information, there are also a lot of doubts about the origins of the plant, because especially myrrh is very important in the world. So most of the time there are some false information because of little information about botanical origin, because sometimes there is adulteration. Adulteration takes place, so that gives also less information about the plant. So we did it because we are there in the center of this plant species, so we took the botanical species, identified them by botanists, and then we did for workers and try to also give information about the origins of the plants, the compounds, like that. So we published some work on this area also. So as you can see here, this study shows this Ethiopian natural gum processing and market enterprise, which is responsible for this. They showed some report from 1992 to 2007-8. There is increase in terms of volume of exports in tons. This is in tons, and values in thousand birr, like 10 million to up to 60 million birr we obtain each year in this time. So every year the value increases, the volume and also the value increases. So mostly these are the countries: China, United Arab Emirates, Germany, and Egypt are importers of these materials we have. And we tried also to publish the information, some ethnobotanical informations, chemistry, and also some pharmacological activities on these resins, and we prepared this book chapter in this book, published in this book. So I also invite you to read this book we prepared. So regarding chemical constituent and pharmacological activities, there are a lot of activities of the plant, the compounds, especially the myrrh and other Commiphora species, against different diseases. So this is a reference for that. So again, even when it comes to myrrh itself, it has a range of biological activities, as I said, like treatment of a lot of diseases for humans, for animals, and so on. So there are a lot of information there. So in this paper, molecules, this article, this author showed that these two compounds that are called furanose-terpenoids, they have activities. They have cytotoxic and also anti-angiogenic effects that were reported from Commiphora myrrha, or myrrh, from the myrrh plant. So these are the major compounds in myrrh. So these compounds have showed this type of activities. And again, this is the result. They worked on human liver carcinoma cells, breast cancer cells, normal umbilical cells, and so on. So these compounds show concentration-dependent activity against these cancer cell lines. And another paper also shows that the anti-inflammatory and analgesic activities of different extracts of Commiphora myrrha were also reported. And this shows that they reported 7 compounds. 2 of them are furanose-terpenoids, and the remains are diterpenoids. And these compounds have also the pattern, the LUPLC dot chromatogram of these compounds were shown from 1 to 7. And these compounds were also have some of these are, as already said, 2 of them are already showed biological activities, and others also were on studies. Again, this even on nature, the effect of these compounds from mercury were already reported in 1996 by Dolorei, and showed that these 3 compounds are constituent of mercury. Among these, the first 2, farmaceuticals and the curazine, these are have analgesic activities. So this work showed this, and this work was published in Nature. So another paper shows that seeing and seen combination of 2 natural resins. These 2 natural resins are also, as I said earlier, frankincense and the myrrh. They are products of Eastern African countries, Ethiopia, Kenya, and also Somali. So these workers show that there is combination of this. When we combine them, when we mix them, they have also increased activities, increased synergistic activity, anti-inflammatory, anti-cancer, anti-analgesic, every activities were increased. So they showed this work. This work shows this one. So this also interesting information. When they also tried to show individual tests, the individual test, and then mix it, then they showed that there is some synergistic activities increment due to this combination. Maybe new compound is formed, or maybe just compounds together can have these activities that can be studied further. Again, even we were suffering from COVID-19, so one of the papers showed that during 3 years, so one of the papers shows that the antiviral and therapeutic effect of mixtures of Boswellia serrata, Commiphora myrrha, and propolis have activities against SARS-CoV-2 virus. So this shows that, again, combination of 3 products. Propolis are from different plants collected by honeybees for forming hives, to seal hives. So these have medicinal values. So when these 3 combine together, they have also this antiviral effect that is shown, where, rather than doing them individually. So this is what was shown. Again, in the eastern part of Ethiopia, near Somali's border, I traveled during my PhD studies, and we isolated 4 new novel compounds from the plant called Commiphora elrangarina. And this, we gave names also these compounds as erlangarins A, B, C, and D. And these compounds, in that area, people use this plant to kill hyenas. Just apply the resins on the meat of dead animals, then they can kill these hyenas. Then I took the samples from there and then extracted and isolated these 4 compounds. These 4 compounds, we also, one of our colleagues in UK did evaluation called Solomon. He did cytotoxic and cytotoxic activity of these erlangarins. And as you can see here, these compounds, erlangarin A up to D, they have poroflotoxin type of activities, cytotoxic activities and cytostatic activities were shown by, were also reported on this journal, Toxin. Again, I shouldn't leave one of the famous plants in India. It is called Commiphora mucul. And the resin that is obtained from Commiphora mucul is called gugulu. I think our Indians are here. And they know it very well. So this is how these plants are prepared to make product out of it. Different products. They prepare different products. And these are the products from the plants, resins, and mixture, and extract, and so on. And these are some of the compounds. This is not only, there are some of the compounds. The major compounds are steroids, terpenoids, and so on. Many compounds were reported from this plant. This is one of the famous plants in the world, known very well in the world, in literatures. And these workers showed that main therapeutic diseases of Commiphora mucul, and they showed that this plant has a lot of uses in different countries, even in not only in India, but also other countries. like in China, in preparations in Tibetan medicine, preparation in Mongolian medicine. So a lot of activities were shown against various diseases, so very interesting plant. So this is also one of the plants that is known when we talk about comifera. And even though there are a lot of information, still a lot of compounds were reported from resins of comifera species, but still less is known about the anti-cancer activities of especially two of the compounds we used for our study. Because there is, of course, previously there are a lot of presenters showed about the incidence of cancer, about 2.6 million every year cases worldwide, and these are including cancer of lung, ovarian cancer, pancreatic cancer, and so on. This problem is worldwide problem. Even in Ethiopia, we also have similar problems. These cancers are leading for deaths in Ethiopia also. So based on this, there are a lot of problems, as already said, like development of resistance against the diseases, and also these drugs, available drugs against the diseases, and also some other backside, some drawbacks, especially the side effects also there. So based on this, we are also trying our best to isolate new bioactive compounds against cancer cell lines. So actually, in Ethiopia, we don't have much facility, as you know, but we have to collaborate with others. We are open for collaboration, so I try to collaborate with people in South Korea, in Norway, and the Czech Republic, and so on. So by using their facility, we try to work some workers here. So the objective of this study is to conduct bioacid isolation and the characterization of compounds from some resins of comifera species, to investigate in vitro cytotoxic activities of crude extract and solvent fractions, again to isolate compounds and to evaluate these compounds against these cancer cell lines, A549, non-small cancer lung cancer line, A2780, ovarian cancer, pancreatic cancer, and stomach cancer cells. So the plants that we choose were two of these. These are Comifera africana and Comifera habesnica. These are also available in Ethiopia. They also give resins, but they don't give much yields like Comifera mirha. These are not commercialized. These are not commercialized. So, but you have these plants. So it is bioassay guided extraction and isolation and compounds characterization with increased polarity of solvents from N-hexane up to N-butanol with increased polarity. So this is facilities for this work. It is liquid-liquid separation. So biological activities are done against 4 cancer lines I already mentioned, with increased dose response from 0.1 up to 30 microgram per ml. So the first result you obtain is the yield. The yield of this plant gives highest yield for chloroform fraction, 86.3, and the lowest was for ethyl acetate fraction, as you can see here also graphically. And we analyze this compound with GCM, these fractions with GCMS, gas chromatogram, mass spectrometer. So these results show that these two compounds are major compounds in this fraction of N-hexane fraction, 33.4%. Cholesterol and cholesterol is 55.7%. There are also other compounds in the fraction. Here it shows the chloroform fraction, GCMS, and again this plant contains, this fraction contains mainly pentacyclic triterpenoids. Pentacyclic 62.98%. These compounds, as you can see here, these are also bioactive compounds reported in literature. Regarding biological activity test, the IC50 values for methanol extract and the solvent fractions were done for Comifera habesnica resins, and this shows that the methanol extract has activities against all 4 cancer cell lines tested. When it comes to the fractions, again, this chloroform fraction showed interesting activities. Others also have some activities. There are For NXN also have some activities. Ethyl acetate has no activities detected and so on. So anyway, this literature shows, there is a literature that shows that within the limit of criteria set by NCI, about if the fraction or the crude extract has less than 30 microgram per ml, we can continue further such studies. So based on that, we did this. So this is a graphical demonstration for what I said, which shows activities of chloroform fraction, methanol extract fractions, compared with etiposide in those response manner. Then regarding isolation of compound, so we isolated, this is a TLC profile. After columnar chromatography using this solvent fraction, we isolated this cholesterol, latosterol, mixtures of cholesterol and latesterol, and these compounds were analyzed by NMR, MS, and IR. So again, we did the biological activities, these cytotoxic activities, these IC50 values for the isolated compound. Cholesterol, when we analyze this, no activities for all cancer cell lines. Latosterol has less activities for A549 and no activities for the remaining. Only mixtures. When the two are mixed, like 1-to-1, they showed activities. That is interesting, especially for A549 and A22780, they showed activities. That was also very interesting results. So maybe the reason for this one is because of some synergistic effect. When they are combined, they bring this type of activities. That's what we concluded, and we also published this work. So this is a graphical illustration of what I said. And this is for Commiphora africana, the second plant. This is a yield. This plant showed highest yield for NXN and chloroform fractions. The remaining are very low, as you can see here, very low, very low yield. And IC50 values for methanol extract and fractions obtained were also done. Again, it's the 4 cancer cell lines. So as you can see here, the methanol extract have showed good activities, especially for A549, and others also showed activities. Again, it's this cancer cell line, but less activities to other cell lines. So anyway, we did isolation of compounds from these fractions to get the pure compound. So this is a chloroform fraction which showed highest activities, sorry for the overlap. So this is graphical illustration of the same thing it is based on concentration dependent manner. So isolation of the characterization of compound of NXN fraction of C. africana, we did that. So when we do that, we obtain a known compound, a known compound, alpha amyrin, and 2 new compounds, Commiphora A, Commiphora B. In this amount of concentration, we try to characterize the structures using different spectroscopic techniques like MS, like IR, like NMR. NMR shows number of carbons, number of protons the compound has. It has 30 carbons, and it is pentacyclic compound, and it has this compound is pure, as you can see here. 2D NMR, all 2D NMR well done, like HMBC, HSQC, 2H2BC, adequate, ROSI, 2D NMR, because we sent the sample to Norway, to the expert of the NMR, so he did all activities tests, NMR analysis. So anyway, finally, this is correlations. But the problem is this compound, this skeleton is known previously. This is a compound that previously reported by these people, but our new compound has derivatization at this point, and the chiral center is not known, stereochemistry is not known. So based on facility we have, we try to also illustrate stereochemistry at carbon 14. So anyway, based on VCD spectra, based on this NMR, based on this RDC, RCSA, we finally come up with stereochemistry of the compound has S geometry. So again, we did the biological activities. The compound also showed interesting biological activities especially against A549 cell lines, and we published this work in this journal. And as conclusion, we have a lot of land, a lot of resources, but we have less facilities. But we are doing our best to cope up with the world, to contribute something to the world. So now we are collaborating. So these are the compounds have, new compounds have this type of activities, as already said. So if we collaborate with more people, more researchers, we can do something meaningful to the world that may have more activities, so we can do something. So now we are starting collaboration with Professor Verano, Professor Anna, and also I have some collaboration in China. Now we started with Professor Wang, and again, we can do further. I think we can do if we want to, honestly want to collaborate. So thank you very much. I would like to thank all of you, the organizers. These are my collaborators. Some of them even I don't know. I just sent sample, but they analyzed it for me in Norway, in Czech Republic. Thank you very much. Thank you very much. So this is my contact address. If someone wants to contact me, we can work together. Thank you.
So thank you very much, Prof. Aman. It's very interesting. Yeah, and we do hope that you will send your compound to us, okay, for testing acanthamoeba or other microorganisms. Yeah. Okay, we can have one quick question for him if you would like to ask, and just one question, yeah, before we close the sessions. Any questions? If no, so thank you very much for your participation and support for these sessions, okay? And we close, okay? Thank you. See you for tomorrow.
Start spreading the news. I'm leaving today. I want to be a part of it. New York, New York. These vagabond shoes are longing to stray.